of what other people did, and so kind of adopted this practice now a bit over years, and it's quite interesting to see what happens when you start just imitating what others do, copy what others do, clone what others do. And so this is, I want to show some of the examples that I did. I also want to address this a bit, or I had this in mind to address this to actually the collaborator here in IT Interactivos, because this is, I think, a very unique and interesting format, that you have someone coming here with his idea, presenting it even in a very early stage. So some people are a bit nervous, like you present that work that you have in your mind very early to other people, and then you ask collaborators to actually join in into this idea or into this project. And so I want to, with this talk, encourage this, to show like what actually can also happen when you actually start imitating or copying what others do or building on top of what others do. And yeah, I start with this slide. You've seen it probably before because I copied it. It's from Mark. It's a slide that he showed like probably 100 times around the world. It's some pictures. There's only, I guess, a few pictures of Mark, Ducey, Anye, Gracie, and Yasha Shetty working here at Interactivos 2009 on this garage laboratory project. And it's where they actually did some space biology, working with microscope, and started this very foundational core of the Hacteria network. I wasn't there at the time. I haven't been the project leader. I was not even project collaborator. I only learned a bit of this later when Mark came back, and it was actually a workshop in 2009 in Berlin where he said, look, I know how to do a microscope just from a webcam. You take a simple webcam and some piece of cardboard and you can do a microscope and see like this microscopic world. And we had an intense one-week session where we basically worked on this microscope and tried to dig into this world of like the microscopic, which you can actually not see by your eyes. But when you build this simple hack of a webcam, then you can go and see this world. And the thing that Mark kept repeating very early on is like this reenactment, kind of reenact what people did when they early started with this microbiology. Because they couldn't see it, they started developing these very easy concepts like a light source and putting a sample, and then with a lens looking through it, and then suddenly see what you wouldn't see. And this is what we kept doing, kind of reenacting this process of going and seeing something that you cannot see. So we discovered all these little things in the water. We went out to collect water samples and looking at this tardigrade, the little water bear, which actually became a bit the icon of Hacteria movement. And we literally spent like days, evenings, nights, just watching at water drops and seeing what is inside and exploring this world of the microscopic. Yeah, this is where actually Hacteria was born, really. Hacteria is a network of open source biological art. Also, it's about building your own laboratory, building open source laboratory. And this is how we became actually biohackers, which was quite early in 2009. By now, this became a bigger movement, also with DIY Bio, more people doing independent microbiology or biology in general. And yeah, it was only later with the poster of Zach that we actually learned that we have always been biohackers. Yeah, I'm very honored to talk here before him. He's going to give a talk later, so I'm looking forward to this. But this is a poster he created, I guess, in India. We've always been biohackers, and that's what we keep saying, like, this is some very natural world, and we're just doing this, what we have always been doing when we work with the nature, work with plants, or grow stuff, making cheese and wine. Yeah, my name is Urs Gaudenz, as I've been introduced. You can also call me the last founder of Hacteria, because I later actually joined and kind of kept following what has been started here at Interactivos. I studied microengineering, so I'm an engineer, and you're going to see like the projects that I present as much more technical than what you have seen before. And I worked for Swiss high-tech companies for several years, developing motor controllers, integrated circuits, and stuff like this. And later on, I also worked in innovation management because I've been a lot in innovation project. I started doing innovation management, learning like how this innovation process works, how actually new things are developed. And it's also through this that I always, when I work now, I get interested in like how are things actually happening, how do people deal with ideas, like, and all this open source is a very new way of creating new stuff, and so this is why I need a sip of water, I guess. Yeah, and then now I almost stopped the industry work. I do basically work in my old lab, which is called Gaudi Lab. I call it a third place for third culture. So this is where I try to combine art and technology. And on the side, I work as a lecturer in innovation management at the Lucerne University, where I teach open innovation, where I also talk to students about how to use all this open source, all this knowledge that is around to create new products. Yeah, so Mark continued with this workshop at Bacteria. He traveled around the world. Here is a picture, I guess, of Yogyakarta, Indonesia, with live page. Akbar Arufatullah, where he teaches people making microscope. He kept like redoing this workshop. Look, this is a microscope, this is a webcam. You can flip up the lens, and then you have a big magnification, and you can start looking at things through the microscope. And this is different workshops. Actually, some is like just helping people that want to have scientific lab instrument. It also then at some point got really into the art practice. We've been invited also to the in Zagreb, the Media Lab, or the Finnish BioArt Society, or even at ISEA Ruhr. We had a workshop doing microscope with people. And so we keep continuing this idea and involving more and more people with basically doing the same microscope, doing the same exploring into the world of the biology. Also, this is a picture from Kenya, where Mark has been to a point-of-care diagnostics workshop, showing people that with very simple means, actually, you can build quite a good microscope where you can see blood cells. And this is, I guess, a blood sorting device that they connected to this to see what is actually going on. We've even been invited to Los Angeles, University of California, at a summer school on the nano art science interface, a quite interesting 2-week program where students get mixed between art and science. And there also, of course, we did the microscope, and we went out in the garden and get some sample, and it was really active and fun workshop. This is Transmediale. CNET Art Festival, there also we had played with agar, little by little we started also playing with other stuff than the microscope, but still always like this reenacting scientific work in a very open environment. And I tried actually a few days ago with Mark to sketch out like how this actually happened over 2 years, but this was too complicated. There's so many workshops in so many places, and this is just as an example of some workshop picture that I took. This is in Slovenia, also an important partner, Biotechna, with the Kapelica Gallery, where we did a hackathon in 2013. We've even been to the XEUT, the center, the European Space Center, actually an artistic space center in Slovenia, and did some workshop there or some field trip. This is Biophilia, Aalto University. Doing workshop with Eugenio Battaglia and Rüdiger Trojok. This is just recent. Yasha Shetty is also still active in the Bacteria, doing a workshop in, I think this is Mumbai, in the RSI Bangalore, where he created, again, a microscope with people you can see on the picture, like they are trying to focus their microscope. And this is actually, even though they're doing the same, they're just keeping doing this microscope, the simple hack of hacking a webcam microscope, it always turns out different, because depending on what material people have, depending on how they're using it, this is a very creative picture of a microscope. You can see like this stage that they built. And I just have some pictures that people built. It's always a microscope, but it always looks very different. This one, very nice, with a big screw where you can screw out the table and then put it in focus, and with some metallic part. suspending. This one, a hand cut, I think is by Lifeparch in Indonesia. Hand sewing from plexi with a PS webcam. They even built like their own. They started producing a bit using parts from the motorcycles and reconfiguring a bit the setup and built quite some of these microscopes that are actually even used in a local university because they just had a lack or they just had this old microscope, and so they started building their own from laser cut plexiglass and the webcam. Oh, this one I like very much with very rough screws, and still it works. It's made just from a scrap pieces lying around and trying to configure it in somehow a way of a stage where you can put a slide and look through. This is, I guess, the first one that I built, a very early hack of a piece of aluminum that was around, and then with a lot of LEDs and starting to build it. This also is a classic, a very first build. This is not from a webcam, but it's from actually a digital camera. So this is why there's even a screen on it. So with the screen, you can see what is going on, and it's a completely like independent unit. You don't need a computer. You can just go out in the field and watch stuff. Yeah, and this is like at some point, some kind of a structure crystallized, which was really like easy to build and stable. This is this inverted microscope, the microscope or the webcam from the bottom, and with these lasers, with these laser cut pieces. And that's when actually at some point when we are in the lab, Mark said, like, look, this is how we should do it. Actually, shouldn't we do like a kid? And he started drawing this this rough drawing, like let's do it like this so we can adapt to different size of webcam and do a microscope like this. And I said, yes, good, let's do it. Made the plan. This is the blueprint for the microscope. It's very easy to cut out from some pieces of wood. You can do it in a fab lab, and then you can put it together, and you have a really fixed and stable thing. We shared it, of course. It's online, so you can download it. It's a PDF, and then you cut it out, and you have all you need to build a microscope. Also, Mark was never really happy with like this stiff thing. He likes when people play and when they try different variations. And this is, even though this looks sleek and is very easy to build, he started like promoting the idea of varying it and changing it. So this is on Thingiverse. We even made a model, like a programmed in OpenSCAD model, so that you can actually change here the material size. If you have 3 millimeter or 5 millimeter, whatever material you have at hand, you can type it in there, and then it's going to adapt the model and create the blueprint so that you can cut the microscope from the material that you have. You can also make it bigger and smaller and change the size or change the size of your webcam, and you have the microscope that you need. And yeah, as I said, he doesn't want to stop there, so when he was in Taiwan, he actually took the same model and reconfigured it again to make a Taiwanese design shape, and I think it looks very nice. Yeah, and so this kind of became even a bit the practice that, like, when Mark sees something online and he thinks, ah, this is good, hey, Urs, like, look, I saw this new project, like in this case, this was an open QCM, so this is actually a new open source project that someone built to measure very small mass, like almost atomic mass. You can measure it with an oscillating quartz. And this is open QCM, so it was openly published, and a very sleek website, and Mark put on Facebook, look at this source. And I saw it, and I was like, wow, this is possible to do. Let's do it. And the same moment, I sat down and started hacking, and we figured out that actually this quartz that you need for this microbalance, you can find it in every computer. So we opened up this quartz and take it out and built this more like simple to build a variation of it, of this product that they just released. And we improved it a bit by adding some extra amplifier or actually circuit to measure more precise. And we published it again, so we kind of took this open development and published it. And later we met the guy, Marco Mauro from the project, and he was like, oh, this is really cool, I like what you did, and we put together here the Hacteria and the OpenQCM. And so he even like said, oh, we should also include this heterodyning. And so we kind of, you can also start like this collaboration. In the beginning, it was like just woo, we published the project, and like 1 week later, already someone hacked it. But still, he was kind of delighted to see this. And here you can see we added this little spike to the 3D printing just for fun. And he was like, because he printed probably hundreds of those, and when he saw it, he was like, ah, that's different. It's mine, but it's still different. I like it. Then another bit more complicated project that I tried to imitate was this OpenPCR. This is an open, actually, DNA copying machine, if you want. It's a thermocycler, a machine that Josh and Tito developed in this DIY Bio. This was really like one of the first important open source project. They made this OpenPCR, which is a kit that they sell, but it's very well documented online. You can download all the source file, all the for the mechanical, electronic, and for the software. But to the point like where I started rebuilding this, they told me never ever someone like really did it on their own. They usually, the people, they like that it's open source, but they buy still the kit. So I thought like, well, let's try and start. I just started by cutting out the case on the laser, and little by little, I tried to find the parts. This is a blower from the PCB. There was an Arduino inside, so I started collecting these things together. In an old fridge, I found the heating element that is needed, and I tried to build it really from stuff that I had lying around. And after a while, to my surprise, I really got together the whole machine. I had to ask some questions because some things were not clear, but they were really happy to help me with what was not clear online. And so I built this, I called it the wild OpenPCR, which is an exact copy, actually, of what they did, just from the information on the internet. Then once I knew how to do it, I continue it, I make it a bit smaller, put it in a small package, and we tested them both, so they worked just from the information that was on their website. And when I had asked this question, they said, yeah, but you're not going to produce kits now and like kind of kill our business. And I said, no, don't worry. It's for me really just the idea of looking into what you did and how you did it. And at some point I found out that actually his wife like did the programming of this very special USB interface. And so I get to learn a lot about how the thing was built by just building the same myself. And there was Shingo, a Japanese friend. He saw this actually, he saw the rebuild that I did, and he was kind of inspired, and he saw that, I want to build one like this, or someone asked him actually to, if he could build a PCR, and he saw, because we documented the rebuild on the wiki, and he saw this, and he started again building a different version on his own. He improved a lot the software, he changed a bit the design, and he even then produced some of them for projects in Japan. And somehow we all got to meet also. This is Tito with Shingo, and Shingo visited me in my lab, and so we kind of created a bit this community of people who built their wild PCR, because I think when you do a project like this, you put a lot of energy, and of course you can sell the kit and maybe become famous that you did it, but if someone builds the same thing that you did, actually, it's something different, because it's yours and still it's someone else who built it and or interpreted it or worked on it or improved it. And that's when you do open source project, is very nice if you kind of see that people work on your ideas and continue on this. I also continued on it, like then later when we had this hackathon that I mentioned in Slovenia, I built this PCR into actually a suitcase because it was quite compact and I knew how to build it. We made this mobile Gen Lab and I built it into this suitcase, a functioning thermocycler or DNA copy machine. And later on we met Betan and Philip, and they were also thinking into making mobile labs, and I think they got quite inspired by the thing that they saw that we already prototyped, and they spent I think a year on iGEM developing this idea further of combining actually this thermocycler with a whole little DNA lab with a centrifuge and other parts, and they just recently launched a Kickstarter, quite successful Kickstarter, where they then again create a new product for the DIY Bio, this Bento Lab. At some point, I was a bit upset with them because even though they have been working 2 years and have a successful Kickstarter and now even go into production, they never really shared their blueprints yet of what they built. And I said, like, come on, I mean, it's time to share also back because I think if you say it's an open bento lab, you should also do it. But they said they will, but they didn't do yet. But somehow, in a bit of frustration, I started again copying their build. So this is kind of a laser cut version of what you've seen before. So this is just the blueprint, and it's very early, but I just thought I'm going to show it that I'm again kind of working on copying back what they do. This is a bit common at the moment, and I think it's quite sad if you see like that this is actually quite interesting to do open source and get people involved in rebuilding or sharing, that some of these projects, especially like the mini PCR, which is another thermocycler, in the Kickstarter they still said it's open source. By now I think they closed source it or they don't share the information. Also this qPCR, which is a kind of a next generation version of this open PCR. It says still open qPCR, and they're working on it since 2 years. They're scaling up now their production, as you can see here, but so far I couldn't find any of the information online how to build it. And when I sent the email, they said they're gonna share the information, so I still hope that it's gonna be a really open source. But it's a bit sad, I think, that it takes some time, or that in the beginning people then still are not sure how early they should actually start sharing their files. Yeah, so we kept in Hacteria doing lab equipment from very simple means like this turbidity meter and other project, and it turned into a whole collection of open source lab equipment that you can see here, like the centrifuge made from a hard drive, this PCR, the microscope. This is a nano drop, a very simple spectrometer where you can analyze very small drops of liquid, incubator controller, the turbidity meter, and many more, the gel box. So this is online, you can look it up, and it's quite simple, most of them to build. Yeah, we come a long way with this, because this was a gathering for open source science hardware that we co-organized recently at CERN. This is where different people working in the field of doing open source hardware got together, exchanged their knowledge or their experience with doing this kind of open source. And I think the general mood was very much everyone is a bit not so sure about how this open hardware world really works, but at the end of the day we were all quite convinced that it's right to do it and that we should go on in this direction of making things open. Yeah, and then I have two more stories that I maybe want to mention. The one is Ginepunk around Clau and Paola. I think Paola is also going to join us tomorrow. They're working on this Ginepunk, which is kind of a project to make open source this gynecology or the women's health, combining with a very feminist, a different approach, doing DIY, all the equipment that they use, and kind of also reenacting a bit this idea of doing gynecology or medicine. And in one session, like actually we had a remote session, and I was looking into this medical speculum that you use for actually examining yourself in gynecology, and I thought like, let's make it open, and we kind of exactly copied the thing that is basically around for many years or for hundreds of years, and it's a 3D printable speculum, so it's just a copy of the design, and we put it on Thingiverse, and so you can download it and print it for yourself. And actually, within a short time, a lot of people started printing this speculum and making it in different sizes and different colors, which is really nice. And it also got a lot of press, so there was a lot of articles online, on blogs, on the Ginepunk movement. And often they use kind of this 3D printed speculum, democratized speculum, as an icon for this movement. And later in Italy, we even built a webcam into the speculum, kind of combining this microscope with the speculum, so you can kind of self-inspect yourself watching on the TV. And I heard rumors there were even like performance using the speculum. which I think is quite interesting to see a different side. And then another one that I did is this space range. Believe it or not, in 2014, NASA emailed actually the design of a space range, which is kind of a tool, to the space station, because they had a 3D printer there, and the guy needed this tool. And so he sent it up by email, and he printed it. And when I saw this, I was like, wow, that's really cool, because this is kind of this idea that you don't need to go to Mars, you don't need to go to the moon. You can send your stuff there, and it's going to be printed, and then you have your object, your physical object, in a very remote place. And I tried to find the design online, but I couldn't, so I was like, I want to print this also to kind of reenact this idea. And since I couldn't find it, I just modeled it as close as I could from this picture. Actually, I look at it exactly how it looks, and I modeled it. And then I printed one. And I was really proud because I kind of felt like this story happened. And it's just like an hour later, Paul in UK, he also printed it because he saw it on Thingiverse. And I'm kind of proud because from Switzerland to England, it's 1,000 kilometers, while from the ground up to the space station is only 400 kilometers. So I kind of also did this, sending the object that I built in my lab to someone else and kind of having then this object in his hand that I designed. And to my surprise, 2 or 3 days later, NASA released on their website the original design of the range, which was actually even like the inside mechanics functioning, so it was a bit, it was even more advanced than what I did, but it looked really similar. Although if you compared it, it did quite a good copy, and it was actually the first tool that NASA released for 3D printing. By now, I think they have 2 or 3 more, which I think is cool, like when you have the things that they develop for space mission, and you can print it yourself at home. So this sometimes also I call a bit NASA hacking, because I'm not sure if there is any connection, but it was still fun to have the object in the first place and then see the original one being released openly. Yeah, I think this is it. So I want to close with a quote from Dirk Sievers that he actually wrote in a famous TED Talk. Leadership is overglorified. It's the first follower that turns a lone nut into a leader. And so I want to also address this to all the collaborators, kind of try to imitate, try to adopt the idea, try to kind of just do what your project leaders do and then see what happens. It's going to anyway change, it's going to be different, and I think it's going to be good. Thank you. Don't know what this is, if there is questions.
Thank you very much, Urs, for your talk. Do you have any questions or comments?
Yes?
Nice presentation. Thank you very much. I like it so much, everything. And I guess it's so useful for these interactivos also, many words that you showed. And I'm pretty sure that maybe some of the projects can ask you more deeper in some of these tools, no? For example, that microscope that can get the image. And I don't know if it's going to fit for them, if it's going to work. Maybe it's good to, they can talk with you and check it a little bit, no? Hopefully these 2 days, time enough.
Yeah, I think we always have some materials for making microscopes, so if anyone wants to do, I think they would be nice, because then I kind of also close this circle, being back here on Interactivos doing microscopes.
Urs is going to be here for some days until Friday, so yeah, he will be around for also for any other questions or help or support for you during the workshop.
Thanks again, Urs. Those of you who don't know us so well, usually we fight a lot and we disagree on everything, and it sometimes gets very loud and people leave the room because it's not comfortable, we fight too much. But still we're on a similar ways of thinking, and one thing that I want to put into discussion now is we very much promote this collaboration and open source, also in artistic production. But still there is sometimes that odd feeling if someone else does the same thing. Or also we feel that we have to make something new. But I think what's the message here is that even just reenacting another piece of work can be an extremely fruitful creative experience. And I was wondering if someone has a personal anecdote of you know, if you're, for example, at art school, you do a piece and someone says, oh, this has been done before. And does someone has a personal experience with this? You, maybe.
I have another one. This one is a funny one also in Live Patch, I guess. Who is it? Woody from Live Patch. He likes to do glitch art. So on his Facebook, he keeps posting these glitch art pictures that they make. And when I was in my knitting period, when I knitted a lot with the electric knitting machine, I actually just took a picture from Facebook and knitted it out. And I put it on, and when he saw this, he was like, whoa, this is my picture, and you knitted it. And so this can also create this back and forth. We did this several times, taking from the internet, doing it in physical and sharing it back. And so, yeah, as Mark said, I think it's very creative also to just try to follow the lines of someone else.
Regarding all these medical equipment tools, do you have a list of what should be next being hacked? I mean, in terms of societal impact, which is the next tool that is something because...
One thing that is around for quite a while is like the open AFM, so the atomic force microscope. There have been several attempts and people built it successfully by do-it-yourself, but there's still no real instruction online, I guess, that you can do. And also at the GOSH meeting, there was a group of students that actually started doing the open AFM, and I'm still looking forward to this. And I also have started collecting the parts to build it, because this is kind of the next level of seeing microorganisms to really see things at the atomic scale. And also, again, the AFM, this electronic raster microscope, is something very kind of iconic for hard science, and to kind of try to build this from do-it-yourself materials and make it especially accessible to everyone so that people can rebuild it. I think that's something that I still want to do.
I disagree. I don't think we need more open tools. We need more people using the existing open tools. So it's good enough to just do whatever already has been done 10 years ago, because still the majority world does not use these open medical tools. And that's for me much more interesting now, but also challenging, is how can we spread that idea that it's good enough to just use an existing tool that is open, then kind of come up with your new pseudo-protected patent invention that's even worse than other designs. You want they have an open AFM project in Villa Prado in the basement.
Okay, check it.
I don't know if maybe, Fran, you want to say something about the...
Andreas.
Bueno, nosotros tenemos un microscopio FM que montamos durante un taller que se dio aquí en Villa Prado hace unos meses. Entonces, bueno, es un microscopio que normalmente es muy caro y que solo pueden permitírselo grandes centros de investigación. Lo que hicimos nosotros, bueno, vino un profesor de una universidad de Taipei que junto con sus alumnos habían desarrollado un equipo, un microscopio FM, por en vez de 200.000 euros que cuesta uno profesional, 3.000 euros. Entonces lo estuvimos montando en un taller y ahora mismo tenemos dos aquí, lo estuvimos probando y funcionaba muy bien. Y Está muy bien porque permite sacar máquinas que normalmente solo están en equipos, en centros con mucho presupuesto, las ponen al alcance de casi cualquier persona que quiera utilizarlas. Ponen la ciencia, digamos, de alto nivel o muy cara al alcance de un montón de personas que tienen buenas ideas pero que no tienen ese presupuesto tan grande. Entonces, bueno, quien quiera verlo lo tenemos abajo. Ahora no funciona porque para medir usa una pieza que se llama cantilever, que esa hay que comprarla porque es muy difícil de fabricar. Son agujas como las de los tocadiscos, pero muy finas. Entonces las tenemos encargadas, pero están llegando. Pero el microscopio lo tenemos aquí, cualquiera puede bajar a verlo.
Bueno, solo por seguir un momento con eso, Fran, en el grupo habéis discutido sobre quién puede usar ese microscopio y para qué, cuáles serían los usos, siguiendo un poco también lo que decía Marc, de no solo pensar en desarrollar herramientas, sino también cuánta gente las usa y para qué, ¿no?
Bueno, actualmente hay como 3 líneas en el grupo de trabajo del microscopio FM. La primera la llevamos a cabo entre una compañera que se llama María y yo, que lo que se basa es en ponerlo a punto para que lo pueda usar cualquier persona. Y luego cualquiera puede entrar en el grupo de trabajo, eso es importante, no hace falta nada, puedes entrar a colaborar. Y una vez que esté puesto a punto, la idea es que cualquier persona que lo necesite pueda venir y hacer uso de él. Claro, o sea, es un microscopio que la intención es que está abierto al uso de cualquier persona que lo necesite.
I just want to comment a bit about this open source movement and open source practice that Hacteria has been doing. In my own experience, that I also create models for workshops, and I come from a very different accessible technologies to where Europe's are now. I come from Indonesia, by the way, and some of the modules that I was producing is actually also inspired from Hacteria and also of course, some other places. And when I developed it and kind of reproduce it in my own kind of interest, somehow I published it in online, and I got a lot of visitors from strange countries from Africa and Asia that really look into this technology, that because a lot of open source information that's available on the internet, a lot of the technology is not accessible for these countries. So I think it's very, very surprisingly that some people are doing workshop from your modules out of different countries that kind of have a similar accessible technology in your country. And this is really, for me, it's really inspiring that you have this open source, your discoveries or your development of other tools, and kind of embrace the community to kind of copy that and also develop that and make it open source. I think it's really important and very inspiring. Thanks.
Yeah, maybe I can add to it. What I try to transport also is like that doing something open is nice, but it's also nice to build something that is open. And just to say, like, we heard this often also a bit with open hardware, yeah, it's good for the poor, they can do it. But that's actually not. It's for everyone. It's very good to copy. It's very good to imitate. It's very good to learn from other people. I think this is an excellent way by reenacting or imitating someone to learn from others. And so that's why it creates this exchange, really, when you also go and do what others do. It's not just giving away or showing what you do, but it's also try to go into and see what others did. And so this gets really like a nice exchange then. I think we have this less bit maybe in the Western culture, in Asian culture, I guess it's more like that you kind of try to learn the whole life. We do it in early school, we have to copy what the teacher does, but then at some point this strange creativity thing comes in where you need to be individual and do your own stuff. And some other culture, it's more that you keep learning by copying, keep imitating, and imitating is like this. It's a nice thing for also the person being imitated, because he's kind of the leader or like the model that you imitate. And at some point, of course, you wanted to try to do even better than what you imitate. But this is like the last step that you're going to do. But for a long time, you're just going to imitate.
In a way, you said you were teaching innovation. Isn't that completely the opposite of what you say? Just imitate.
Yes, I mean, this field also evolves. So maybe in the beginning you teach like, yeah, create a creative environment, think out of the box, all this brainstorming, whatever. But at some point, you can also, when you really, that's what I meant, if you really look in the way things develop, you can find also new ways to create new things. And I think especially this is quite a misunderstanding often that someone that you think came up with the idea really came up with the idea. What I saw over time much more is that everything is a lot a continuum. Like most of the people that do something also, we saw it in the presentation this morning, got an inspiration again from somewhere else. And I think the fact to acknowledge that I actually took this idea from someone and built on it, and I'm proud of it, and I'm proud of the person who did it in the first place, and it's kind of, I do it also for him to imitate it. This creates then much more this continuation. That's what I try to show it, like one project builds on the other and builds on the other again. And I think that's much more honest also when you work with ideas, to acknowledge that you took from somewhere and that you continue and that you want someone to take from you. Instead of like doing this, wow, this was just a creative inspiration came out of the box in that creative moment, which I think oftentimes is not the case. Yeah.
So what I see in our Fab Lab and actually my own work is sort of the innovation, or what we call innovation, is mostly like version 2.4. So before that, I start with 0.1, and I actually copy myself through the whole process and just do something better or do something different. And just because the number goes up doesn't mean that it actually gets better with any iteration. So, and sometimes it takes a leap, and sometimes it's really gradual. But I think that's why I wouldn't call my work innovation. I call it development. And I rarely see that like something pops out of the sky and just falls into the lab of somebody, and it is a perfect idea. So I would say, to comment what you said, is, well, why not just skip version 0.1 to version 1.8 by just copying, like let somebody else do this, and then you take it from there. And since around here we are sort of between science and art, well, we're half scientists and half artists then. So the scientist part of us should actually acknowledge that a huge part of science is trying to reproduce what other people have done, just to verify if they were right or not. It's actually one of the hallmarks of science. And as artists, I mean, whatever field you're in, you know that you actually build on a huge number of layers of what other artists have done before you, be it code, be it painting, be it sculpturing, or using matter, or whatever it is. So don't be afraid to just, you know, pick up somebody else's work. Everybody else does it. It's what you said before.
Along those lines, I found it really refreshing, the perspective of repetition and mimicry within the context of a lot of times. I feel like technology is driven by trying to be the first to do something or creating something that's never been seen before. And sometimes that bleeds over to art that has to do with technology of, oh, we've never done an artwork in a virtual world before. Okay, we're gonna do an artwork and sometimes so much value is placed on novelty, and do it for the first time, that other motivations such as the process and other creative motivations get lost. So I found this an interesting perspective.
Yes, yeah. We also started doing a bit the joke when someone says it's the first in the world. Usually it's very bad stuff because almost nothing is the first in the world, and often when you do, it's more like presented in a way as if it was the first. But exactly when you look into how everything came together, you see there's often no first in the world. Often it's related, like you just said, like it's related on previous work, and it continues and it combines, and then it grows out of this. And I think also for people looking at all this fancy and crazy new stuff, it would be more helpful to know a bit the background. How did this come together? Who was influencing? Who was inspiring? And what was it based on? And then you can start building this picture instead of just popping up something very surprising. And it's still nice when there is a very new combination, but this is not very often, and it's often presented as being more different than what it actually is if you know a bit about the background.
Thank you very much, Urs.
Thank you.